Welcome. Let's understand the intermediate value theorem. So let's say that we have one condition. Let's say that we are working with a continuous function. Therefore, there will be no holes and no gaps in the graph. So let's draw this continuous function in some interval. Let's call it a and b. So we're going to start at some point using the x value of a, and we're just going to have a continuous function until we get to some point using the x value of b. So let's call this continuous function f of x. We can be more specific on the coordinate point that we started our continuous function. The x value that we use is a. Well, the way that we can define our y value, it's only by an expression, which we're going to call f of a. It is a result that we obtain when we plug the value of a into the function of f of x. And now if we concentrate on the point where we end up our continuous function, the x value that we are using, it is b, and we do not know what the y value is, but we know one thing about it. The y value that we obtain, it is the result when we plug in b into the function of f of x. So let's call that f of b. Now what will happen if we choose any y value between f of a and f of b? I'm going to choose this y value, whatever that is. Well, if I draw a horizontal line, I can identify what was the x value that was used for this specific y value. Notice that the x value that we obtain, it is some x value that is between the initial interval of this function, between a and b. Now, will this be true for any y value that we choose between f of a and f of b? Let's choose another one. Now, let me choose some y value that is very close to f of b. Well, let's draw a horizontal line and let's see what is the x value that was used for this location. So this is where we intersect our graph. So now let's draw a vertical line. Notice that we obtain the same result. If we choose some y value between the section of f of a and f of b, the x value that was used for that location, it's going to be some x value between the interval of a and b. And even if we would have chosen another y value that is close to f of a, if I draw a horizontal line, and I look at the intersection on the line, and then I draw a vertical line to figure out what was the x value that was used, I'm going to obtain the same result. If I choose some y value between f of a and f of b, then we will always end up with some x value between the interval of a and b. As a result, we can say that if we choose some y value between f of a and f of b, we will always use some x value between a and b. And that is what we define as the intermediate value theorem. So this is the general idea, but let's actually write down a mathematical definition for it. We can say that if we have a continuous function, then for any value of L between f of a and f of b, so let's just choose this one here, then there exists some value of c between a and b, where if we were to plug in this c into the function of f of x, it's going to give us the L between f of a and f of b. So this definition, it's nothing more than the result that we obtain. If we choose some value between f of a and f of b, then there exists some value between a and b that if we plug it into the function, we will obtain the value of L. A common mistake that I have seen is for students to choose some value of x and then use the intermediate value theorem to find out some value of y. Notice that this is the opposite direction. We will always choose some value of y, and then the intermediate value theorem guarantees some value of x. So notice the direction. We choose some y, and then we are guaranteed some x, not the other way around. And this is only true if we have a continuous function. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.